So welcome. This now discuss about dispersion. The optical signals becomes increasingly destroyed as it travels along fiber. This distortion is due to the dispersion effect. So the dispersion when an optical signals or pulse is sent into the fiber, the pulse spreads or broadens as it propagates through the fiber. This phenomenon is called as a dispersion, as shown in the figure. So from the figure, we can see that the pulse received at the output is wider than the input pulse. So hence the output pulse is said to be the destroyed due to the dispersion effect. So the pulse broadening or dispersions will occurs in the three ways: intermodal dispersions, material dispersions or chromatic dispersions, and waveguide dispersions. So intermodal dispersions. So when more than one mode is propagating through the fiber, then the intermodal dispersions will occur. Since many modes are propagating, they will have a different wavelengths and will take different time to propagate through the fiber. So which leads into the intermodal dispersion. So when a ray of light is launched into the fiber, the pulse is dispersed in all possible paths through the core, so I call it different modes. So each mode will be different wavelength and has a different velocity as shown in the figure. So hence they reach the end of the fiber at a different time. This results in the elongations or stretching of data in the pulse, thus causes the destroyed pulse. It is called as the intermodal dispersion. And material dispersion. In material dispersion, the dispersion occurs due to the different wavelength traveling at a different speed inside the fiber zone in the figure. So the material dispersion can be minimized at a certain wavelength, say 870 nanometer, 1300 nanometer, and 1550 nanometer. These wavelengths are termed zero dispersion wavelength. So whether light wavelength is lesser than the zero dispersive wavelengths, it travels slower, and when it's higher than the zero dispersion wavelength, it travels faster. So thus the speed is altered and adjusted in such a way that all the waves passing through the fiber will move with a constant speed, and hence the material dispersions are minimized. This dispersion will not occur in the single mode fibers. Waveguide dispersion. So the waveguide dispersions arises due to the guiding property of the fiber and due to their different angles at which they incident at the core cladding interface of the fiber. So in general, intermodal dispersion greater than material dispersion greater than waveguide dispersion. So the fiber optic cable, how to reduce the various types of losses in optical fiber already discussed. The fiber optic cable, which is lighter and small and more flexible than the copper, can transmit signals at the faster speed over a longer distance. So however, many factors can be influenced in the performance of fiber optic transmission. Losses in the optical fiber, serious issues among them. So it has been top priority, even engineered to work with figure and solutions for the articles offers the comprehensive explorations and the resource of fiber optic losses and proffers pragmatic remedies and ensure the seamless efficient network transmission solutions. So dispersion. Thank you.